In this video, maintenance models and the cost of maintenance will be covered. This is a second part of module 5 of software engineering and project management. Like process models, the maintenance process also has different types of models. Like quick fix model, iterative enhancement model, Bayes model, Bilali-Lemon model, etc. So we are going to see each of these maintenance models now. So first one is a quick fix model. The quick fix model is basically an ad hoc approach to maintaining the software. It's a firefighting approach, waiting for a problem to occur and then trying to fix it as quickly as possible. That is, the the system is working, and once some kind of error occurs or some kind of problem occurs, then you try to fix it and then again continue operation, and again when you find a problem then you fix it. So it's an ad hoc approach. Then next type of model is iterative enhancement model. In iterative enhancement model, what you do is you analyze the system, then once you analyze the system you find some kind of modifications are required, then you do characterization of the proposed modifications, then you redesign the system and then implement it. So it happens iteratively. Once you implement and develop a new version of the software, you again analyze the system, find new modifications, characterize the proposed modification, again redesign, and this is happening iteratively. That's why it's called the iterative enhancement model. Then another type of maintenance model is reuse oriented model. The reuse oriented model means you try to reuse some parts of the old system to develop the new system. Okay, so what we do in reuse oriented model is you identify a part of the old system that are candidates for reuse, understand these system parts, modify these parts to be appropriate for the new requirements, and then integrate this modified parts into the new system. That's what we do in the reuse oriented model. You use the parts or maybe the entire application or any module of an old system to a new system, into a new system. Okay, so that is a reuse oriented model. Then another model is Bayes model. In Bayes model, the Bayes proposed a model for maintenance based upon economic models and principles. So the Bayes is representing a maintenance process as a closed loop cycle. So this is an economic model. So once you evaluate the system, you evaluate the current system and you propose changes or propose modifications, there will be a management which takes the decision on whether this changes should be implemented, whether it is economic to the economic to make that change. So once the management decides whether to approve this change or not, and if they approve the changes, then only you are going to implement this change. So then the change implementation occur and a new version of the software will be developed, and again the result will be evaluated and they or analyzed, and again you find some kind of changes, and this proposed changes will be given to the management for further decision, and this is a closed loop cycle. Okay, that is Boehm's model, which is an economic model. Then you have Tote maintenance model, and it's typical maintenance model that has 8 phases, and it goes in a cyclic fashion. That is, in this model, you first make a change request, you estimate the uh, cost of this modification, schedule it, then you code or program this, that is, you modify the system, then you test it, you document it, and then you release the new version, and that will be operated in a regular manner. And once you find some kind of uh, changes are required, you propose another change request, estimate, schedule, program, test, document, and this goes in a cyclic fashion. That is total maintenance model. Then you have two models, Belady Lerman and Lerman model and Boehm's model, which are basically uh, a quantitative model. You basically use it to find the total effort used to uh, develop used to develop a particular system. So in Belady-Lerman model, the total effort expended, that is given as M, is equal to P plus K e raised to C minus T. That is, here P is a productive effort that involves analysis, design, coding, testing, and evaluation. That is the effort that we have taken to develop that particular system. That is P. Then K is the empirically determined constant, that is some kind of constant that is empirically determined. And C is the complexity measure due to lack of good design and documentation, or the complexity of that particular program. And D is the degree to which the maintenance team is familiar with the software. D is the uh, degree of familiarity of the software. So with this you can find the total effort M. So here is an example or a small problem based on this Biladi, Lehman and Lehman model. So in this question, the development effort for software project is 500 person months. The empirically determined constant K is zero point 0.3. The complexity of the code is quite high and is equal to 8. Calculate the total effort expended, that is M, uh, if the maintenance team has good level of understanding of the project, that is D is equal to 0.9, and also you have to find the total effort expended M when the maintenance team has poor understanding of the project, that is D is equal to 0.1. So you have everything, that is our equation is M is equal to P plus K into e raised to C minus T. So you have the value of P, that is the development effort for the software project. P is 500 person months. Then you have the empirically determined constant K. K is 0.3, C is 8, and the value of D for the first question it is 0.9, and for the second it is 0.1. So with this you can simply use the equation to find the total effort. So here This is the solution for that problem. Uh, so the first question, where D is equal to 0.9, the total effort M is calculated, and the answer is 863.59 per month. And in the second problem, when they have a poor understanding of the project, that is when D is equal to 0.1, then the total effort will be higher, that is 1309.18 per month. So that is one way to find the total effort taken for a particular system, development and maintenance of the particular system. Then you have a Boehm's model for this, for finding this total effort. So in the Boehm's model, they have a quantity called annual change traffic. Annual change traffic is a fraction of a software product's source instructions which undergo change during a year, either through addition, deletion, or modification. It means that ACT is the percentage of the source code that is modified in a year. Annually, how much of the source code is changed? That is ACT, or annual change traffic. So if you have the value of ACT, then you can find the annual maintenance effort, that is every year how much maintenance effort is used for a particular system. So if the maintenance effort the if the ACT is given, then ACT into the SDE is software development effort in person months. ACT into SDE is equal to the annual maintenance effort, AME. SDE, software development effort in person months, is the effort to develop that particular software, total effort to develop that software. And now you are going to find the annual maintenance effort using this SDE and ACT. So here's an example problem on this Boehm's model. Here you have annual change traffic for the software system as 15% per year, and the development effort is 600% months. You have to compute the annual maintenance effort. If the lifetime of the project is 10 years, what is the total effort of the project? So you have to find the AME as well as the total effort for the project. So you have ACT, the value is 15%. So the annual maintenance effort will be 15% of the development effort. That is 15 by 100 into 600. That is 90% month. That is annual maintenance effort, or the maintenance effort in 1 year. So for you find the AME as 90 PM. So the maintenance effort for 10 years will be 10 into this annual maintenance effort. So the maintenance effort for 10 years will be 10 into 90, that is 900 month. And so the total effort will be the effort for development of the software, that is 600 PM, plus the maintenance effort for 10 years, that is 900 PM, that is 1500 month will be the total effort taken in 10 years for that particular system. So that is all about the maintenance models. Now about the cost of maintenance. Most of the reports suggest that the cost of maintenance is very high. That is, a study on estimating software maintenance found that the cost of maintenance is as high as 67% of the cost of entire software process cycle. That is more than 50% of all other phases. Right? Requirement phase, designing, implementation, and testing is uh, is only the rest of the uh, cost. That is about 67% is used for maintenance, and only the rest is used for all the other phases. So there are many factors uh, that trigger the which trigger maintenance costs go high. Like there are some real world factors as well as software end factors. The real world factors which course courses increased course is given here. That is, the standard age of a software is considered to be 10 to 15 years, but and older softwares which were meant to work on a slow machine with less memory and storage capacity cannot keep themselves challenging against newly coming enhanced software on modern hardwares. So that is one of the reasons for increased costs for maintenance. Then as technology advances, it becomes costly to maintain old softwares. That is another reason. Then most maintenance engineers are newbies and use trial and error method to rectify problem. That is another real world problem. Then often changes made can easily hurt the original structure of the software, making it hard for any subsequent changes. Uh, and another problem is changes are often left undocumented, which may cause more conflicts in future. These are some of the real world factors that can lead to increased costs. Then there are some kind of software and factors also, like structure of the software program. If the programs are not properly structured, then the programming languages used, which are not adaptable to the new technologies. Then dependence on external environment, staff reliability and availability. These are all some kind of software and factors that can affect and increase maintenance costs. So that's how the maintenance costs are high, or it is more than 50 percentage of all other SDLC phases. So that's all about maintenance. Thank you. Thank you.